So let me bring you guys over to my screen. So here's what we are looking at for today. So tomorrow our next lesson is going to be lesson 10.5. But again, there's some algebra in there that you guys haven't probably done for a while. So I wanted to go through this with you today to prepare you for some of the algebra you're going to need for tomorrow. So we're going to start out with these two right here. And typically, whenever people look at a quantity squared, oftentimes they think they can just distribute the exponent, right? And so they call it x squared plus 9. Can't do that. So you have to think back to, what does it mean to have something squared, right? It means it has, you're multiplying something times itself. So technically, right now, we are going to do x plus 3 times itself. All right, so this is really what x plus 3 squared means. All right, it means we need to multiply that thing times itself. So we're going to start with going through our distribution. You guys might have learned this as FOIL, right? The first outside, then inside, then last. So you might have called this FOIL. You might call it double distribution, whatever you want to call it. I basically have to distribute the x to both of those first, and then I'm going to distribute the 3 to both of those. So let me just start with the x. So if I multiplied x times x, we're going to get x squared. And if I multiply x times 3, I get 3x. All right, now I need to distribute the 3 over to here. So if I multiply 3 times x, again, I'm going to get 3x. And if I multiply 3 times 3, we get a positive 9. All right, so there's our distribution. That's all the whole idea of double distribution, or FOIL, if you learned it as that way. The one last thing we want to do, though, is combine like terms. So I'm going to combine those middle two to finish it off. All right, I know that 3x plus 3x is 6x. And so that's the way this needs to finish. All right, so when they give us something like x plus 3 squared, right, this is what we need to be able to come up with. We're going to try that one more over here for practice. And guys, by the way, you are turning in these notes, so make sure you're taking nice, clear notes here with what with what I'm giving you. So let's try the same thing with x minus 8 squared. So probably the easiest thing to do for now is let's just recognize that we can write that out twice. X minus 8 squared means x minus 8 times x minus 8. So we're just going to start by writing that out twice. And then we're going to go through our distribution. So we're just going to start with distributing the x to both of those guys. So if we did x times x, we know we get x squared. And if I do x times negative 8, we get negative 8x. So the next thing we're going to do is distribute the negative 8 to both of these. So if I did negative 8 times x, I get negative 8x again. And if I did negative 8 times negative 8, I get a positive 64. And then always simplify whenever you can. So like, let's combine those middle two. We know that a negative 8x and a negative 8x is going to give us negative 16x. All right, so that's where that would finish. Guys, does anyone have questions on, and guys, I'm not going to be looking at the chat while I'm going through this, so if you have questions, you just need to speak out. Okay, so please tell me if you have questions, or if you need something further explained or whatever, you just got to let me know. All right, so one of the other things that we're going to look at tomorrow within that lesson is factoring this. Factoring is basically the opposite of what we just did. In fact, let me back up and show you this, right? In the problems I'm going to give you now, you're basically starting here and you're ending here, right? It's like it's the backwards process of distribution. So factoring and distribution are basically opposites of each other. Okay, and so the way that we will factor these guys, and there's multiple types of factoring. This is one basic type of factoring. So when I recognize that there are three terms, right, we got the x squared plus 11x plus 24. So if you have three terms, we can factor these guys by looking at any two numbers that would multiply to be 24, that would add to be 11. So we're trying to think of what are two numbers that would multiply to be 24. So what are factors of 24 that would add to be 11?
8 and 3.
8 and 3, you got it. 8 and 3. So guys, here's how we're going to write these as factors, right? So, and obviously again, guys, take a look, right? If I multiply them together, I get 24. And if I add them together, I get 11, right? And that's what we're shooting for. So they're both positive. So if I have a positive 8, I'm just going to write that factor as x plus 8 because it was positive. If it was negative, I'd write it as a minus. My 3 was also positive, so we're going to write that as x plus 3. And that's it. Those would be the factors of this guy. I'm hoping you guys remember that process. I know you've all learned this in algebra, but like I said, it's probably just been a while, so hopefully this is all ringing a bell for you. And you guys know that if you really ever wanted to check your answer to know that it was right, just do what we did up above. You could distribute these guys to these guys, and if you simplified it, it would put you right back to where you started. Because remember, distributing and factoring are opposite processes. So let's try that with one more here. I tried to throw in some negatives too, just to make sure you guys saw the difference. So we're going to try to figure out what are two numbers that when I multiply them, I get negative 35. But if I add them together, I get negative 2. So right away, hopefully you're thinking of numbers like 5 and 7, right? There aren't too many numbers that multiply to be 35, so we don't have too many options here. So let's look at 5 and 7. So here's where you got to be careful with your signs, right? One of them's got to be negative because when I multiply them together, I get negative 35. So one of them has to be negative and one of them has to be positive. So now we have to decide, okay, so which one gets the negative so that when I add them together, I get negative 2. So it's got to be this guy, right? So now if I multiply those together, I do get negative 35. If I add them together, I do get negative 2. So I know those are my winning numbers. The 5 was positive, so we would write him as x plus 5. My 7 was negative, so we're going to write that as x minus 7. Those would be our two factors.
Mr. Smith.
Raul, what do you got?
Oh, I forgot to change my name. I'm sorry. I was in Spanish class. It's Isaiah. Sorry, but I got confused on the 35. It's negative 7 because it's a negative 35, right?
Correct.
Okay. Just making sure. Thank you.
Yeah. So, but I'm glad you asked. So the one thing that you do got to be careful on this is which number gets the negative. So if I would have put the negative here instead of here, that would have been a problem because negative 5 plus 7 does not add up to negative 2. And I got to make sure that whatever these numbers are, that they add to give me this middle number. So that's how we need to put the negative with the 7 and not with the 5. All right, guys, let me further that process for you. So we only got 3 problems left to go. So take a look at these last 3. Guys, when you first learned those factoring techniques, all of it led you into this process where you are now using factoring in order to solve equations. And so that's what we're going to take a look at here to finish this off. So let me start basic for a minute. There are some cases where I don't need factoring to solve it. All I have to do is get x by itself, right? And that's what I'm seeing here. There's only one x in the problem. right? So my goal is simply to get this guy by himself. So let's solve it the way you would solve any equation, right? If this is a -7, we're going to do the opposite, and we would add 7 to both sides. Because remember, and keep this in mind, and you'll see why I'm saying this in just a second, but when you solve an equation, our goal is to always do the opposite of whatever operation we're seeing. So when we see a minus, then we're going to say, well, then we're going to add 7 to both sides. Or right here, when I see multiplication, this is 3 times x squared, I need to do the opposite and divide. So we would divide both sides by 3. And that would put us here. So what is the opposite of x squared? What is the opposite operation of squaring something?
Square root.
Square root. You got it. So we're going to simply square root both sides to get our answer, because the square root of x squared is simply x. On the other side, the square root of 4 we obviously know is 2. So there's one little extra piece here though that we have to consider. If I'm looking to solve for x, I always want to look at numbers that if I were to take this answer and plug it back in for x, I want to make sure that it fits, right? So there's actually another answer that would also fit this equation. Does anyone know what I'm missing from my answer right here?
Square root?
That's a good guess. I think I heard someone just say it. We're missing a plus or minus sign. So maybe this looks familiar to you. So the rule is, and this is a rule you would have gotten from algebra, is anytime you take the square root for both sides of an equation, you're automatically supposed to put in a plus or minus, because both +2 and -2 fit this equation. If I plug them back in for x, they both fit. So we're supposed to state both answers. Now, one thing I want you guys to keep in mind when we're using this in geometry tomorrow is if x represents the length of a segment, well, then you may not be able to keep the negative as part of your answer, because you're never going to have a negative length, right? And so that's something we're going to have to consider when we look at tomorrow's stuff. But for today, we're going to put the plus or minus because it's just algebra. All right, let's try this one. Guys, when you're solving, these are all called quadratic equations. When you're solving quadratics, one of the first things we try to do with these type of cases is we want to get everything onto one side. So what's the difference between number 6 and number 5? If you guys look at number 5, you notice that there was an x squared, but there was no x. That's what makes this one a little different, right? I have multiple x's in here. So whenever I see that scenario, the first thing I want to do is put everything onto one side. So the first thing I'm going to do is add 5 over to here. So do that with me. So I'm adding 5 to both sides. So this is what it looks like. I wanted to get everything onto one side to make it equal 0. And the reason we're doing that is because we're going to solve it by factoring. So that's why we just looked at factoring a second ago. So numbers that would multiply to be 5, that would add to be 6. We don't have too many options on this one, huh? 1 and 5. So those are the only two numbers that would multiply to be 5, that would add to be 6. So I know my factors are x plus 1 and x plus 5. The difference on this now, though, is we're not just factoring an expression, we're actually solving an equation. So this has to go an extra step beyond what we did up here, because this is now an equation that we're solving. So here's where all this led back in your algebra days, is we would say, it's something called the zero product property. What is anything times 0? It's 0. So if this equals 0, then that makes the whole thing equal 0. Or if this equals 0, again, the whole thing would equal 0. And that's what we're trying to figure out, because That's our solution on the other side. So in other words, oh, that's supposed to be a plus. So if x plus 1 could equal 0, what would our solution be? Or if x plus 5 could equal 0, what would our solution be? So let's just look at the first guy. So if I were to solve for x here, I would solve it by subtracting 1 from both sides, right? So I would get -1 as my solution for that one. On this side, I would subtract 5 from both sides. So we would get -5 as our solution. So those are our, So those are our two answers, right? So again, usually when you're solving a quadratic, you typically get two answers, right? That's kind of the normal here, right? And so for this one, those are going to be our two answers, -1 and -5. Guys, I do want you to consider though, you only do that process when you're solving an equation. If you look at the difference between 4 and 6, 6 is an equation, 4 is an expression, right? 4 is just an expression that we are simplifying. Number 6 is an equation that we are solving. So this one came with some extra steps because it was actually an equation that we were solving. All right, we're going to do one last one here and then we'll call it good. This one's a little simpler because if you look at this, first of all, I'm recognizing, oh, hey, I got the x squared, I got the x. So just like I saw with the last one, I do want to get everything onto one side. So let's just start by subtracting x squared from both sides of the equation. So we're just going to subtract x squared. Well, this one's kind of an interesting case because if I do that, my x squareds cancel. So let's just bring down what we have left. All I have left on the left side is my 100. All I got left on the right side is 6x plus 50. So this one is a little easier because my x squareds canceled. And now I'm just solving a basic equation for x. So we would start by subtracting 50 from both sides. So that would put us here if we subtract 50. And then we would divide both sides by 6, which obviously 6 does not go into 50 evenly, but that's okay. So let's just leave it as a fraction. You could change it to a decimal if you really wanted to, but we don't have to. So what I was trying to give you guys today was some of the different scenarios that you're going to run into tomorrow when you guys are doing lesson 10.5, right? So there's going to be some times tomorrow where you run into these situations where you might need to square something or you might need to solve an equation, right? And so I wanted you to see the 3 different types of equations that you're going to end up solving when we get to lesson 10.5. Guys, does anyone have any questions on this before I switch gears and talk about something else? All right, so let me